I welcome you all to our first Electro meet. Myself Subhash, second year term 2 student of Electronic Systems degree. So today we are all here to discuss about an interesting concept of electronics, that's embedded systems. And there's a lot we have learned in embedded systems, and we are going to now share our experiences about it with you all. So this session is going to be very interactive, and I would request you all to be very interactive and ask the questions or even pauses in the between. And it's going to be very interesting. We have planned a lot for you all. I would request Namai and Prakar to take up the stage.
Hey everyone, guys. I hope you're doing well. And as Venkat just started this week, we're saying that it's gonna be awesome. Indeed, it is. So first, I am Namai. First of all, also a second year student here, doing the ES degree. Anyway, so we're gonna start this off by first of all telling you what the use of embedded systems is. As in, why would someone want to learn embedded systems if they're not intrigued and interested by the fact that what it can actually do? So we'll probably first start by giving you some spoilers to show its possibilities, so that you kind of get hooked in, and then we'll impart all of the knowledge. Let's start off with this very trending thing that I made a while back, 2 years to be precise. This is basically an Iron Man helmet. Okay, what have you ever wondered how does all of that work? Well, it is all embedded systems, even the nanotech, everything. So keeping that in mind, this is what I made. It is a simple Iron Man mask. So you can actually, it has a touch sensor. You touch it and the head can go up and down. It also has an app. So with that, you can control the lights. I did this in like class 9th or 10th. So that's why. Excuse the finish, but I think I did a decent job on the electronics part when it comes to the factory light. So yeah. So the brains of the system, everything is basically, I used two boards for this. I use an Arduino Uno for the servo part, because essentially at the top we have a servo. As you can see, this is the side part. I use a servo in order, and I connected that with the touch sensor. That is an Arduino Uno. And for this wireless capability, I used an ESP. So that is how it communicated with the touch sensor and also your mobile phone. This is just one of those examples which you can make. Now, this is a very rudimentary thing that I made. You can go much more deeper into it. Similar to this, I also made a Spider-Man mask. So I hope we all have seen Spider-Man. In that, the eye shutter basically move for Peter Parker to express his various emotions with eyes. So for example, if he's like angry, he would frown. You can just see the eye socket right now. The socket basically just overlaps, and so for example, this might represent that he's angry, right? So as the eyes squint. So this was a nice thing that I made with ESPs and servos again. And you can actually wear this. Even the other thing you could actually wear, you could see me wearing. So if you're interested, I'll leave a link. You can probably check this out after the video. So basically, this is the ESP connected here. It's all embedded system. It is all embedded system. Right now, I'm using like a microcontroller, but I could, in theory, also make everything from scratch using PCBs. Also, Pokemon is like very common. I made like this Pokeball with again using ESP. So this is like all of the electronics that went in, and the finished product was actually extremely close. So you can actually control how much it opens with an app. Probably the world's first thing that kind of operates. So see, this is how it kind of worked. So I kind of 3D printed, but that is like secondary. My main aim is to show what embedded systems can do. Now for some like action-packed stuff, I made this Cybertruck, which you might have seen because I got it for Paradox as well. But anyways, this might not be the best example for embedded systems because this uses a remote control, RC stuff and all. This was my third attempt, and that's why I went with the RC technology, because it was like very specific to what I needed. But when I attempted it like way back when I was just getting started, this is what my approach was. Again, I used my old and trusty ESP, and so basically everything was, I mean, I did the design part and all, added shockers and all, but what I want to tell you is I actually used an app to control it, and again, the brains and the hearts of the system behind all of this was nothing but an ESP. So you can see the mobile app on the side of the screen. That is how you actually control it, front, back, left, right. And you can also control the speed, lights, everything. And also there is a slider that you can slide for the back trunk to open, like in a real Cybertruck. So I hope this you can probably see this part if you just pay some close attention. So yeah, that is what I wanted to show. And probably for the part, it's this is probably the last thing that I would want to cover. Even a mouse, for example, something as basic as a mouse, even that has embedded systems, all of these chips and all. So everything essentially that you use around you, be it these headphones, your mobile phones, everything, they do use embedded systems. So yeah, I think you got a fair idea. To do anything related to this, we need to go in depth, and that is exactly what my friends here and me, we're gonna do in this through something which we'll reveal at the end. This is what our main aim is, to have sessions and all. But anyway, I would now give this to, over to Prakhar to discuss some more things in detail. Prakhar, you're good with sharing your screen, because there's a PPT that we wanted to share with you.
Sure. So hello everyone, myself Prakash Srivastava, and as of everybody, as Nama and Subhash mentioned, I'm also a second year term student at Electronic Systems. So let me give you a brief overview about what Nama had said, and let me share my screen. That's all.
Yeah, and Prakhar, while you're sharing your screen, I think there was a hand raised. If that was accidental, that's fine. But if it wasn't, then if you can raise your hand again. Yeah, since it is our interactive sessions, we are indeed kind of entertaining questions. Yeah, Tarun, you could probably unmute and go ahead.
Hi, Nami and Praga. Actually, so basically, can we say that embedded systems, it's just a thing? We can, with the help of embedded system, we can control devices. Can we say that?
Yeah, correct. So, see, Tarun, we are coming on that only. So let me give you a brief intro about what embedded systems is. I believe then you will get a very good idea what actually it is. So let me share you my screen. So as Navi mentioned, so how does all these things are working? They are machines, right? They are not living beings. How they are even moving? Very big question. So the answer behind this is somebody behind is controlling. Somebody like the hand of the robot, wheels of the car, the Cybertruck which Nama has mentioned, something is controlling. So here's that magical power which is controlling that machine. Do you know what it is? It is a microcontroller. It is that power which is controlling the wheels, the hands of a robot, the servo motors of the Iron Man headgear. This is what it is controlling. Don't you think how this is controlling? It is controlling that which we are wanting it to control. How even we are talking to this microcontroller. So that is something which we have to answer, and that will be answered by the thing which you look at this. This is what embedded say, programming. Okay, this is how we communicate with the machine, microcontroller, and microcontroller talks to the peripherals, the wheels, the hands of the robot, like everything. Okay, so this is what the way we have written, and in modern computer science, this is known as the code, by which we talk to the microcontroller. Inside a microcontroller, there is a CPU, which is, FT of instructions. It always says, what next, what next, what next. So they give these instructions to that CPU, this is next, this is next, this you have to do, this you have to do. So this is how the billion instructions per second is given to the CPU, and the CPU is controlling the another thing, which is output peripheral of a robot or something, right? So combining all of these inside a machine, that what makes it an embedded system, right? So an embedded system is a combination of hardware and software both. Okay, hardware and software both designed to perform a specific function within a larger system. Okay, unlike the general purpose computers, embedded systems are not often dedicated to a particular task, like controlling a washing machine, a microwave, or even managing electronics in your car covers around the embedded systems, right? What is inside the embedded system? Okay, so as you can see, the embedded system consists of the microcontroller, which is the brain of that memory, in which the instructions, your instructions are stored, which is being processed to the microcontroller, and then it controls the further peripherals. The input-output interfaces, like the hand of the robot, wheel of the car, the Cybertruck, and of course the power supply, right? Power supply is very essential, and without that, nothing will work. I think everything is useless. Like around us, we all are covered with embedded systems, right? So one day when I was talking to Namai, he was sharing some of its insight in some of his projects which he has made using some of the simulator, I believe. Yes, Namai, is it true?
Yeah.
So can you please share those so that everyone can get a better in real feel how they can achieve making these systems which we have made?
Right. So there are two parts to it. Simulation is one, but I am always over to the real hardware part. See, we resort to simulation when we don't have the components physically. But but here luckily I do have the boards with me, right? For example, this is an ESP32, and if you don't have the hardware, that is perfectly all right. You can go to Circuito.io or even Walkme, which we'll discuss later. And these are like simulation softwares. You can go, and simulation is basically how your board will behave with a certain hardware while you're not having that board or the hardware. So it is basically creating it's a fake environment that we make to predict the actual behavior of the components, in simple words. And I think you'll agree with it, right? And so the simulation part, it's not it is actually very specific to the project that you're doing. It's not that one simulation would be enough for all. As the hardware and the sensors and everything, peripherals that you attach, they change, and then so does your simulation, and so does the behavior.
Yeah, pretty much. It adds everything. So, Subhash, can you please proceed further?
Yeah. So it seems like a very formal introduction towards embedded systems by Nama and Thakkar. Now let's make the things very simple. Yeah, I guess Madhur is around with us. Madhur, if you can turn on your video. Yeah, in the meanwhile, so can some of you name, by the overview we have given, can some of you name any embedded systems around you? Any one or two, at least in the chat, or you can unmute yourself. At least what you think as embedded systems.
We just discussed Iron Man's has embedded systems. So, less positive. Yeah, indeed. Air conditions have embedded systems. These smart ones, how they regulate their temperature, their phones. I mean, guys, too many spoilers. Go ahead.
Hey,
Yeah.
so
use that.
if I may, what is embedded system?
Okay, so embedded system. Okay, let me put it in this way. So with the overview given by Thakkar and Nama, you may ask like, okay, it's just like writing a piece of code for certain hardware. We have learned many coding languages. Yeah, this is very simple. It's like bread and butter for us. What's the point of even learning it as separate subject, and what's the point of even learning it extensively? We get to the point. So embedded system is way different from the actual computer which we use. Every program which we write in Python or you say C programming, Python, Java and all, you write for an actual computer which is sitting on your desk. But the story is very different for embedded systems. For example, let me present something.
And just to make it clear, so those of you who are looking at this for the first time, it will look difficult, but very honestly, it is simple. You can ask anyone. You can ask Venkat, Thakkar. I mean, we were clueless about all of this code probably till the last cent, right? Isn't it? But the moment we did embedded C, and it hardly took us like 3-4 weeks of like proper in-depth doing it. And I think all of us, at least, should did embedded systems. We do have a fair idea of how a code works and what it does. So yeah, 3 weeks maybe is all it takes, isn't it?
Yeah, very true.
Nama, in the meanwhile, if you can share the screen with the temperature ready bar project, please share it. So yeah, Madhur, if you are available, turn on your mic.
Yeah.
So
Yeah.
okay, now let's take an embedded system which is in front of me. It's a Bluetooth speaker.
Okay.
Let's break down what's inside this. So yeah, what does a Bluetooth speaker do? It does play the music. It connects to our mobile through Bluetooth, and it does play the music, right?
Yeah.
So
That's right.
now definitely, if some piece of hardware have to do certain functionality as we wish, there should be some software running it from the behind.
Correct. Yeah, because I feel chip is a non-living thing.
Yeah, we need to give it a set of instructions. You would say, okay, I have done my digital systems laboratory, I have done the counter without any software and all. Yeah, that's true. Those chips it's completely different. Those are meant for doing one functionality. If you make a counter, it does only counting. If you make some other thing, it does only that thing. But here, Bluetooth C, we can use this in various modes. There are few functional buttons over here. I can turn it into Bluetooth mode. I can turn it into auxiliary mode. I can connect through the cable and all. So yeah, that's not a single functionality. There's a lot of functionality in there. So what's running it all? See, now here you can see there's a piece of code sitting beside and there's a hardware running beside. So now the whole thing, this whole code is being run in that white color piece. If you can see my video, this is the board which is being shown there. This is known as STM32. Things may look very very complicated.
So, and do you mean that this embedded C puts a sword into the non-living thing? That is a chip.
Yeah, you could say.
Oh, okay, interesting. What more can it do? Like, we usually hear artificial intelligence. How is that helpful here?
So artificial intelligence, it's completely a different story from here. Let me give you some more overview about what's embedded system. So yeah, you could say like I know programming. So Madhur, you know programming a lot. So you could ask me like, I know programming, what's the point of doing a whole course separately? What I'm doing exactly was writing a program. So actually the difference between the programs you write and the programs we write in embedded systems was, in Python or in some other code, do you usually take care of how much memory is being used and all? In visual codes?
That's I just buy a good computer and it does it.
Yeah, but that's not the case here with embedded systems. See, for example, I have a Bluetooth speaker. I can't include an Intel i5 processor into to do the functionality which I'm doing in it. It has very limited set of hardware. Like, you could say like very limited set of like a CPU which is running at some kilohertz, like some 1000 clock cycles per second. So you can ask, what's a clock cycle? Clock cycle is a term which a CPU takes to complete one instruction, completed to run one instruction. And I'm not sure what's the amount of memory in this, but I am sure that it's in some order of kilobytes, not even kilobytes, some order of bytes and all. So that's the main point. You have very limited set of hardware with you, and you need to optimize your code in such a way that it's the particular limited set of hardware is being able to run it. Now, one more question, Madhur. So, what do you usually do if your code crashes in between or some unexpected thing occurs when you are running your code?
Like in your ideal sense or in the today's sense?
In today's sense.
I just give it to GPT.
Okay, so you are actually like trying to debug it.
Yeah.
Well, you can try to debug it or you can install fail-safe systems.
Yeah, that's
Yeah.
GPT does for me right now. So how do you do that in embedded C?
So actually, you people have, I guess most of you are familiar with this memory overflow, and also it's taking, if you're for example, if you write a Python code to go through some 1 lakh lines of data, then usually your terminal freezes, right?
Correct.
What's actually happening over there was the memory is being already filled up. So what do you everyone do when your terminal freezes or your replit or VS Code freezes up? What do you usually do?
Let's switch it off and restart.
Yeah, you will restart it. When you restart, the memory will be started from the beginning. So, say for example, even an airbag mechanism is an embedded system. See what it's doing. It's continuously measuring taking in the data from the crash detection center, and it's just processing it. If there's some abnormal changes in the crash detection sensor, it is going to deploy the air balloon. So, see for example, I've started my car. I'm going and I've written a code such that the memory overflows. Now I'm about to hit the car and the memory overflowed. What's my position?
Okay. So it would restart it.
We have to restart it, but that's not the case now. When I'm crashing, it's not like, okay, wait a minute, I will just restart my car and now I'm going to crash.
Yeah,
So there is
I would
something.
go to the repair shop.
No, but yeah, that's true. But when you are going to crash something, you can't say that, okay, I'll go to repair shop and crash once again. So one thing as an embedded engineer, we have to keep in mind was we should anticipate what are all the possibilities there for such kind of crashes and all, and we should cut down them in the beginning stage itself. And that's something which we are going to learn extensively in this embedded systems as part of embedded systems. So yeah, there's a lot more.
Okay. And you mentioned there's some magical thing coming up. What would it be? Like, was it this?
Actually, there are some nice softwares written by humans, something known as IDEs, where you write in basic C language and it converts automatically into the type of work you select. But that's a different story. So whatever the interface you are seeing on screen is known as walkway.
Yeah, Subhash. So, like you said that that embedded C is that small device and a limited set of memory
and it also has some issues with power consumption and all. But here currently I'm running my laptop Intel Core i7 12th generation. It is a very powerful processor in this. So what is even the need of why I use this small hardware, these weak things? I can simply do everything with this my strong processor. What is the need of embedded system?
Yeah, very nice.
Yeah, interesting. Why? Yeah, actually, why do we need to spend our time on those small machines when we have a big machine?
Okay, so yeah, so Namai, is it something related?
I want to answer.
So the answer to this question is you cannot lift your laptop to your washroom and listen songs there.
No. Actually, the best answer to this is, if you're saying do everything in simulation, why don't you travel watching YouTube videos?
Yeah, that's true, but
Things don't work like that, right?
yeah, that's true.
The car
And
to go from point A to
No, he wants specific things to work specific tasks. Every time general purpose things doesn't work.
In fact, to do the simulation also you need a hardware, right? And that hardware is nothing but embedded systems. So yeah, it's like a closed loop, and you don't need hardware.
So
But
like
then,
trying to say, like you're trying to say that for listening, for example, a particular song, we don't need an Intel Core i7 processor. We just need
definitely.
one.
no, if you start including Intel Core i7 processor even in my car airbag and all, then my car cost will rise up to some lakhs or crores even on a normal basis.
Yeah, correct.
And even there are, even
It costs only 100 rupees. My Bluetooth headset costs 100 rupees, and my laptop costs 50,000.
yeah, if you start including Intel i7 processor in everything in your cars, there are many embedded systems like the dashboard display, the horn system, and even the MP3 player or Bluetooth player in your particular car. If you start including, your car price goes up. Like even your Suzuki car cost up to equal to Benz car.
Correct.
Yeah, so there comes engineering is all about trade-offs.
Even like when more things arises in my mind, like we are currently thinking embedded systems as only a cost-effective device, but a missile is also an embedded system which is very costly. But it depends upon accuracy, how accurate you want a system to be, I guess. So there are
That's all. There are trade-offs, and the reason of doing a separate course on embedded systems is to make the student or embedded engineer mature enough to take these decisions and to decide what to trade off in a right. That's all comes with your experience, and the more you learn, more you expose for the projects. Yeah, Vivek.
And you need to choose between, you need efficiency, power, speed, and all of this to choose a perfect microcontroller for your project. If you are talking about something, you need a super high speed. You need to calculate your velocity, angle, acceleration, everything in a second, in microsecond. So that will need an expensive.
yeah, that is what I was thinking.
Yeah, that's what I'm talking of.
Yeah, you have risen up a nice point. Like everything should be done in a very quick manner. So this is one more factor which we will be considering in embedded systems. Something known as real-time accuracy. Real-time doesn't mean like very fast enough, but see, it should be like we usually set a time threshold. Like for example, if some crash is detected in your car, the airbag should pop up within some milliseconds. So being an embedded engineer, we also take care of this aspect while writing the code, that while there is some interrupt happening, the effect is generated very quick. It's not like very right away, but it's like within an permitted amount of time. And we make sure that while processing this data, the CPU is free. This is something else we will keep in mind while writing programs or designing embedded systems.
Good afternoon, good evening, sir.
No need to call me.
Actually, sir, I have doubt in C programming OPP. So my OPP is left. So can I expect some good internship without that?
Basically, embedded C, it's all about ideologies. Once you get to know about the idea,
No, sir, not embedded C. C programming.
yeah, better to complete your C program, OPP.
No, sir, OPP is left. So can I expect some internship without that?
It's not possible. It's very
I want to just do internship in that field only. So that's why I was asked.
Definitely, Kishan. I don't think you are able to do Python and Linux without completing C. I guess you have completed C. Recheck your grades.
Okay, sir. I will recheck and
Yeah.
Thank you, sir.
Okay.
Thank you, Namai.
Christian, we do have a opening with us. So if you want a C internship, do let me know. We want.
I don't want that.
Okay, my sure. Kishan, being your friend, just missing up this. Yeah, Namai, if possible, share the screen.
Yeah. Okay, guys. Carry on. Bye. See you.
Yep. Bye bye.
He dropped the sir.
Subhash, now you're testing my patience, huh? Want to eagerly know what's that surprise?
Oh, why should I announce it? But do I know embedded C?
Okay, let's do one thing. Let us all announce it.
Yeah.
We will announce it in one sentence, and we'll say one word of that sentence. Okay. So, for example, I'll start by saying, "Okay, so we are announcing."
Whoa.
Okay, jokes apart, the name of our club is World Talks. So, the main motto behind our club was, see, most of the meetings or the sessions which we are going to have in our club going to be in a similar kind of fashion. Today, only me, Namai, Madhur and Prakhar with a little glimpse of Aditya, Prakash and Pradam, we are interacting. So, we are planning to make a club in such a way that everyone will be interacting, everyone will be expressing their thoughts, and we will be learning something like, we will be learning something together. We'll be developing our ideas together and we'll be sharing our ideas. So this club is not, specifically or it's not narrow-minded to embedded C. And it's like, we will open it very soon for each and every concept of electronics. So what's our main motto was, whatever the concept you have, we will be learning from the basics. We'll be getting to know the intuitions behind everything.
Okay. So now I'll pretend if I know everything, though I do not. So the club is basically Volt Ops. So, and it's Volt and Ops. Interesting. So it's basically going from the lowest level where no one went. Of course, Thomas Alva Edison might have went, but no one in our generation went. Like, what's behind I cross R, or what's behind I, what's behind R. So that's our focus. Like, that's our goal of the club. What we want to do is we'll go back to the roots from where it all started. No MOSFETs, no BJTs, just a simple resistor. And let's see what's inside a resistor and why do we need a resistor. But again, to start with the interesting stuff, we will start with what was a tough name, Venkat, which you were playing along with in the entire session? I do not know it.
Is it STM32?
Yeah, that. So we'll be playing along STM32. Yeah, and and this is one of the motive of our clubs. We wish to interact with all of you. Anyhow, we are not meeting in person to everyone. So please click on your videos, interact with everyone. If you join our club, you will be seeing 4 of us, 5 of us, 6 of us. A lot. You might get bored with our faces, but you'll have to see us. So please search all your videos.
Yeah, we have.
Okay, so first of all, thank you Namay, Madhur, Subhash, Prakhar for taking this step. Okay, you're also a student and you're also doing these courses, and you have taken a great step for juniors. So yeah, I just want to say thank you for taking this step, and I hope I learned a lot about embedded systems and embedded devices from this club. I would love to join this club.
So we have planned many Easter eggs in the coming days as we go with the timeline. Make sure you doesn't miss the Easter eggs.
introducing the new community, which I'm pretty sure it will help all of us, Voltops. And to know more, make sure to join the WhatsApp group and see you there.